So I'm going to run through real quick basically the scenario that Paul presented to me on his 11 job. So there was some control that gotten wiped out, Paul. Is that what the original situation was? The project control, that the PC1 sheet that came along with the project, some of the points were missing, and so we were going to come back in there and set some additional control to facilitate the construction of the project. And so Paul sent me an email with what he wanted the location of his control to be, where the plan was. So these guys in purple here, so that for this project, I believe Ned and Jason went out and picked this spot for this base station, and then the contractor built like a mount so they can mount a base on there. And then there's another point that Paul and crew went down and set down here, and then they set another point over here. And I'm not sure if BTW was build the wall or by the wall.
Or by the way.
By the way. By the way, there's a control
It's up to your own
point over here.
interpretation. I left it open for color commentary.
So, so these and these are the parameters, and so what we're looking at, and Paul's telling me what control he wants to use, and these are the points that he has here available. These 3 points. One of the first things that we do when we're planning a control survey is we can go into our specifications. Well, I mean, this is my Bible right now. I want to make sure that I can meet some of these requirements. So, depending on the level of accuracy that you want, there's certain guidelines that need to be followed. One of the things that is the monument spacing, monument type,
Where you set it at?
and the type of monument. Yeah, so I mean, if you were going to put a first order control point out there, you can't set a 1-inch pipe. It has to be something better. It has to be a disc. If you're trying to achieve first order 1 centimeter accuracy work, you can't have any points that are closer than 2,300 feet. They have to be spaced out greater than 2,300 feet. If you're looking for second order work, and they changed the way these things are written. This is in lieu of first order, we're calling it 1 centimeter, and in lieu of second order, we're calling it 2 centimeter network.
That's what they call positional accuracy, as opposed to the traditional way of looking at it.
So, and then
Orders.
on my report, if I'm gonna, and then network accuracy versus local accuracy, and then 2 centimeter local accuracy is basically third order, and we need the minimum spacing of 500 feet in order to achieve that. So one thing to keep in mind, if you guys are thinking about doing a control survey, or you want me to come help you, or anything like that, just consider these. Look at this sheet right here. I think I sent this to everybody. So if you're going to go out and set points, they need to be of a certain character type and a certain spacing in order for us to achieve a certain level of accuracy.
And that's all is in the survey manual too.
Yeah. So, and I mean, and so I've done surveys where something wasn't met. And then almost in all cases, I couldn't meet one criteria or another. And it was probably poor planning for me, or maybe just getting ahead of myself, or whatever, or going out there and trying to just rush it, I guess. And down here on the bottom, it refers to a note. Static GNSS methods required if baseline lengths are greater than 12 miles. And then if you're going to use static there's a certain length of time that you have to observe these points, and in this case, there's another sheet I'll show you guys, but. So here's what the survey manual wants you to use as far as documentation. The final GPS survey project should contain the following. I'm not gonna go over all these things individually, but just know that it's there. They want a least squares unconstrained adjustment results, and they want a least squares constrained adjustment results. So.
Just before we go, I'm sorry, I'm going to ask some questions as you try to explain these. Do you guys know why we have a unconstrained and a constrained adjustment? This applies more to surveyors than the rest of the group here.
I have something I can demonstrate it.
Okay.
So.
How about project control?
Yeah.
9135 versus current.
No, constrained and unconstrained adjustments.
Show your work versus how you fit the network.
Correct.
Unconstrained will just show you
How your work holds
decent
together.
Your gun working GPS is within itself.
That's a simple way of putting it. So, just floating out without any, with everything basically unknown, and then just using geometry. And then if you got a triangle, all the interior angles need to add up to 180. Or if you got a figure, it's n minus n times 180 or whatever that formula is. It's just the mathematics behind it. So, if with unconstrained, you're checking that everything makes sense.
And you're holding one control point versus the project control.
You can do it with none too.
None, yes.
Johnny was asking me some challenging questions the other day, and we actually learned something. So, I don't know if I'll go over that right now, but so office procedures. I just went through and I highlighted some things. So one of the things you look at is your loop closures. It's basically, that's again the same thing. It's how your geometric shapes close on each other, and then talks about your loop closure in more depth, the least squares adjustment. If you're trying to do a B order, which is greater than first order, and then here's your first order specifications. So you're looking for 1 in 100,000 accuracy. Generally, static GPS survey methods are required. Dual frequency receivers need to be used. We have that. And then, so here's like the table that you need to follow. So, static or fast static. So if your points are greater than 12 miles, then you're gonna follow all the criteria under the static column. If your points are under 12 miles or whatever, you're gonna follow all the criteria under the fast static column. One of the challenges that Paul's project had is this very first, this third item right here. So if we're going to call it first order work, we need to be constraining to first order control or better. So if I got 3 points and one of them's a second order, then the best I can do is second order. The next thing that they want is 3 quadrants. You need reference control. You need basically your constraints in 3 quadrants of your project, and it doesn't have to be cardinal like northeast, northwest, and so on. It just, no matter how you slice it, as long as you basically have geometry with your project. And in this case, it was challenging because I had none. All my constraints were all right up here on this north side. So I was kind of like curious on how the results were going to be with, after it was all said and done. But here's all my constraints. It's all basically, and 2 out of the 3 quadrants. I mean, if I lay the quadrants out like this way, kind of thing, I get that and that. So just going down the list. I mean, this is something that this definitely right here will help you at least wrap your head around how you need to plan a control survey. If you guys are going to help me, if I'm going to help you do it, and you have an idea what the project is and what you want. So independent occupations, you need to occupy every point at least 2 times. 10% need to be free or more. Minimum observation time. See, like on for example, on the survey we did on the 11, we did 10-minute sessions. I didn't I brain farted on this. I didn't say 15 minutes. I thought 10 would have been good because normally rapid static is like 8, so I just went with 10. If we would have done 15, it would have been better. And then if you're doing regular old static, you do 30-minute observations. You got to have a minimum time between your observations of 60 minutes.
If you did the 15 minutes, you may have been within half a hundredth as opposed to 100th.
Well, yeah, so there you go. We did, yeah, we cut quite a few corners on this, and I'm just calling it second order.
And we still built a watch.
And yeah, and it's gold plated. So and we did it all in a day. So maximum loop length, that's like basically all your sides of your triangle added up. You got, so you don't want to exceed that. Sometimes that gets exceeded. I did a survey out in Kern where I had like 90 miles. Here, this misclosure per your loop, 10 ppm. Everything that I did on the 11 was better than 4. I think the worst one was like 3 something. This is why I like to use 2-meter fixed heights when we're doing this. Antenna height measurements are not required when using fixed height antenna poles. According to the manual, if you're not using fixed height and you're using a regular old tripod, the operator is supposed to take a measurement
Twice.
before and after, just to make sure that somebody didn't fat finger a height. Just take all that out of the equation and grab a 2-meter fixed height. That's my opinion.
So it has a good bubble, by the way.
And check the bubble.
We go through them.
The survey is only as good as those
Exactly.
rods,
So-
yeah.
So then it goes through, we got specifications for second order control. Now we're down to 10 minutes, so that's what we achieved. And then 20 minutes for the static, and then 45 minutes between occupations. And then there's an ephemeris, and that's the other thing. When you're trying to do first order work, you got to get the precise ephemeris, and that takes a few days or a week to get from whatever organization produces that, because they got to download the orbit of the satellites and then figure out the exact orbit. So even if Paul wanted first order results on his project, I would have had to wait a week or whatever to get the precise ephemeris to produce that.
Question. 45-minute minimum between occupations. Is it like, okay, we all showed up to our next session, wait 45 minutes and then fire it up and go?
Well, at the same point, like if you occupy, I think it's if you occupy this point, and then you go, and then if you're gonna, and you do a 10-minute session, and then come back to it, and you're occupying it again within 10 or 20 minutes.
Okay, so if you're gonna
Or like
occupy-
back to back kind of thing.
So you're gonna occupy the same point twice in one campaign. Make sure it's 45 minutes in between both occupations.
Yes.
Yeah, that point could be occupied by somebody else, though.
Because like you had Bob sitting on the same point for where me and Jason were moving around, you know.
Yeah.
So that as long as you're on the same point, you can do back-to-back ops.
Just keep it
Or you
running.
can just keep it running.
Bob did one.
That doesn't violate
No.
that 45-minute minimum thing.
But you know what? I'd probably have to ask the powers that are greater than me on that one.
It doesn't seem it would be a violation as long as you're waiting.
I mean, I think one of the
The satellite geometry is the issue here. You want to
Right,
change
you're waiting
the
for-
satellite geometry so that you're actually creating more redundancy and creating more confidence in the work that you're doing. So coming in 10 minutes, the satellite geometry didn't change enough for you to actually have more confidence in what you're doing.
And that applies to your existing control that you're constraining to and your new control.
Everything.
Yes, everything. Another thing
This
on
is
the
good stuff, yeah.
on the ephemeris, I just want to talk about broadcast ephemeris. We know where these satellites at any time where they are in the sky, and it's basically they give you a schedule where they're going to be.
the prediction.
It's a prediction of where they're at. In reality, the actual location of these satellites changes based on conditions or whatever other factors. And if you want to know where the precise position of that satellite, you got to wait a couple of weeks because the change in the position of the satellite changes the position on the ground. Now, it is minimal because of the distances being so far away. The changes on the ground are minimal, but you're still better off to wait to get the actual position of the satellite, and that's where you got the signal from, because
Well-
you're doing these space.
And I also think, based on conversations with my predecessors, like before, these standards were put in place when we only had how many satellites? When it was just
Yeah.
GPS.
Yeah, good
And,
thing it's 8.
and now we got the Russians, and then we got the, now the skies is full. So, yeah, he's proven that some of these criteria don't matter, after, because of the way it's advanced.
I used to do my own processing, and Steve would go through the procedures of producing his own, doing everything right. And I don't remember a time when we were different by more than a couple of millimeters.
Yeah. So yeah, here, precise ephemeris may be used for second order, and then we'll be back.
Let me explain. I'm not asking you or condoning my method of doing work, because I wanted to get value so I can actually do the work, and he was going to produce the actual stats that look good. My stats never looked as good as his. My confidence in the work that we did was high, but if I gave my report to somebody without actually going the procedure of eliminating trivial lines and doing all that stuff, Kevin will cover, but again, I did not see much of a difference in actual reality of doing the work, whether I followed procedures or just processed the data without a precise ephemeris.
So, minimally constrained. So here's my minimally constrained adjustment on the work on the 11. So here you put your settings in there. So your error, your centering error, and the field work was so good. I can't take all the credit. Paul's guys did great. Checking their tripod bubbles before they went out there. Because it was the most happiest when I had this at 0.
But typically, do you put in 100th?
I usually put in depending. I mean, I start off with half 100th.
But then it improves your stats actually if you put in an error in the centering.
Well, it depends. I mean, if the work is better than, like, if I put in 5,000ths and my result tells me that my actual work is better, then I'll drop it down to 2 or 3, based on what
Would
it
you like
says.
a minimally constrained and you've got it like a 0.6 or 0.7? You'll change that.
I'll tighten it up, because that means I'm doing
Yeah,
better.
you don't have to hit the button twice, huh? That's good.
Yeah, so here's my iterations passed, and then this is what it looked like. This holding 1 point HPGN, the best point we had out there, and we hit. We had northing and easting on the one that was in the northeast corner, which was this guy over here. So this guy and this guy disagreed with, by this much. What I determined that to be was a rotation. Once I snapped to this point up here, everything was happy, and that's what I did.
So was M1411 made? Did it come off of the HBGN?
Well, see, that's other things. So yeah,
M1411 might be a county survey
That's an
monument that we
NGS.
inherited from them.
I believe that was an NGS.
They're both
Was it?
If it was built for, if the two were interconnected before and then you start missing them, then yeah, but.
I don't believe
separate.
that they're related.
No, they're not.
They were done with 2 different campaigns.
Yeah.
Me and Dave and I never really got into the history of either one of them. We just know that Tim Dickey always used them in the airport and M1411. I mean, we're talking since the 90s. It's quite a while ago, and we can't have a little bit of movement in between those 2 points.
Well, and so one of the things that we do have to do, I mean, that's part of the planning, and I was gonna go into that. I'm kind of getting ahead of myself, but yeah, we go, and I do all the research, right? So I open up whatever document that produced that value.
Just like being in the back of the bucket.
Open an Internet Explorer, by the
Oh,
way.
no, that one, one of them was giving me trouble, and I found it a different way, I believe. Or no, this one I think was the one that was giving me trouble. This one was the one that I wasn't too happy about.
I never, 4.0 was set by the private sector,
Yeah, and
and
then
they
so
built the 125.
if I go through and I look at just look at the way they like. I probably should have had this already like indexed, but when I see the results of their adjustment, it was obviously had a big problem. Let's see if I can find it.
For those of you that don't know, the 125 toll road was not built by us.
We set the control for it. I set it with Dickie.
Yeah, but the private
Yeah,
sector
the
is
private
the ones that did all the construction staking and the
The
private rocket
right-of-way.
control.
Right.
And the right of way, independent of us.
We just check the bridges, that's all. The one on the north side, where it joins 54, and then on the south end, yeah.
So yeah, this thing failed with the reference factor
Oh,
of
wow.
almost 5.
Yeah, that was bad.
And they didn't try to take care of that.
No, they got like this is what I did. I went in here and I looked at this, and it's like they're not, their settings, and then so this right here tells me that there's a problem in their work somewhere. So
That's the run constraint.
let's see if
It's not a report I would give to anybody.
no.
What's showing?
Remember
Yeah, that's constrained adjustment. I got 8 constraints.
Yeah.
They probably
Yeah,
tried to
from my
constrain it
eyes
to too
only.
much.
Yeah, 8 points.
8 out of 14.
Well, even
That's why
then-
they probably got a high scaler.
Something happened, but anyway, when I saw that, I'm like, I'm gonna let that one float. So,
Floaty.
and so I made a statement in my report that okay, so let me go. So background minimally constrained adjustment, and then
And how did you detect that it was a rotation between HPGNC 11 and 1411? Once you
just when I snapped to the 2, I still was. Then everything was happy. Well, I mean, I was hitting that point still good, relatively good. I mean, that was all I could. I mean, that was all I could do because I only had those 3 points.
Sorry.
Yeah. So here now I'm holding 2 points horizontally and vertically, and I'm still hitting this KP, 3x4, 1200 to now.
Never been level 3.
Yeah, and so here. This is what I wanted to hit on kind of what Ned was talking about with the iterations of control on 5, and you got generations. Documentation is, so here I got the minimally constrained adjustment, so that right there shows how all the stuff holds together, and then a partially constrained adjustment that's the second iteration, and then I got the third iteration, which is basically the final, and then it also spells out, in more detail what I did. And so that helps when you're out there and you're doing a survey and you're going to go jump on some control, to be able to go back and go, find the paperwork chain and
Right.
go, what happened, and why did the surveyor make the decision to do this or to do that? So,
And Dave was the first guy that really started doing that, because if you look at all the stuff before Dave,
It was horrible.
you just get this lat long coordinate
Yeah.
convergence angle combined grid factor report.
Yeah.
right,
You,
well,
you don't know what was constrained you. You don't
It
know
was good work, but it was like they never gave you
There was
enough
no
information.
well, that was my gripe, and that was what I was saying. That where guys like Ned have been here, and he was here when it happened, and he knows what happened or how it happened, so he can tell the story. But without your story, we don't know when we're doing the research.
Yeah.
Me personally, I've been using Dave's stuff. I mean, as soon as I started acting as a party chief, Dave was right there, kind of coaching me, and he was sharing. He was basically sharing with me his methods. So I've been trying to make this work and learning from it since then. So again, the final adjustment, I still got the zeros for the centering error, and where's my factors at? 95. For 1.95 to 1.
That's as good as you can get.
And so that tells me that the field work is good. So that's why it's very important when you guys are out there before you, if you're going to do any kind of control work for, even if it's just third order, whatever, check your rods, adjust your bubbles, you know, take that out of the equation, because that can really cause a headache. Trying to chase that down. And then I found out later on that Paul leveled through his point down on the very south end, so I held that vertically, so I have three points constrained to vertically, better up here, which is this guy down here, and then this guy over here, and this guy over here. So here's what the whole scheme ended up looking like.
And your vertical accuracy on your points and the leveling through these points affects your horizontal results. With GPS, it's a 3D type of a survey. It's not just a 2D survey. So having good levels, leveling through points, will affect your end results.
And we actually, historically, throughout the whole corridor from M1411 to Palm Avenue and 805, we always had 3 centimeters in the vertical. And we could never figure out where it come from and how to get rid of it. And so Alfonso, myself, and Jason, and a few other people helped. We run levels all the way from M1411 all the way out to the 805 corridor, down the Bayer Avenue, up to Palm Avenue, and we located 3 NGS benchmarks that agreed. And we constrained to 2 of them and backed out the adjustment through the whole corridor. And M1411 ended up having 1300ths of a foot in the vertical.
Okay.
Yeah. That's why I sent you those values. I'm like, yeah, don't use that, use this, because this is the good elevation.
Yeah. And once I got all that plugged in, and this was all happy. But this is one thing that we're always going to have a challenge with. I was talking to Scott Martin, who's our NGS coordinator, or geodetic coordinator up in headquarters, and because I had another control job out in Calexico when we were doing the border stuff, and I'm like, how do I got this border and I can't go, and I'm doing work right at the border. I can't get anything down here for my.
You're up, Johnny.
Well,
Bring your passport.
And
Bring
so,
a drone.
so Mexico does have an NGS station down here, but I think that was during the government shutdown, and I couldn't get any that data from it. But he said the same scenario they deal with on the coast.
Yeah, there's no water.
So, this is one of the challenges.
Gotta do what you gotta do.
Yeah, well, this is one of our challenges. So, so going into the
boat.
so I'll just go over real quick how I came up with the plan, because so when you're doing geodetic surveying, you got to have, there's all these other little criteria that you got to meet. One of them is having dependent and independent baselines.